Now we're going to discuss full adder. Here, in this presentation, we are going to find the logical expression for the sum and logical expression for the output carry. This box, you can see here, it is your full adder. And what is inside this box is the combination of the logic gates. You can see that input A, B, and C input is the three input for this full adder. And the sum of the carry and the carry output are the two output of the full adder. So how are we going to find out the logical expression inside this box? Here, I have already made the table, inputs A, B, and C. And depending on the input, we will try to find the sum and carry. We're going to add A and B and C input. Now, 0 plus 0 plus 0 is equals to 0 and carry 0. 0 plus 0 plus 1 is sum is 1, carry 0. 0 plus 1 plus 0 is equals to 1, carry 0. 0 plus 1 plus 1 is sum is 0 but carries 1. 1 plus 0 plus 0 is 1, carry 0. 1 plus 0 plus 1 is sum is 0, carry is 1. 1 plus 1 plus 0 carries 1, 0 is the sum. Now 1 plus 1 plus 1 is equals to 0 here, and then plus 1 is equals to 1. So the sum is 1, the carry is 0. 1.
So the next step is to make a two-variable K-map. And why two-variable K-map? Because it has three variables involved, and 2 to the power of 3 gives you an A. So there are total of 8 cells K-map. So these are 8 cells K-map. We'll write first the LSB. B, C input. Then A and LSBC input, we will need to draw another table because we are solving the carry output. Input. And now we will fill up the first K-map for sum, and second K-map is for the carry input. Carry input. Now you can see first is 0, 1, 1, 0. 0, 1, 1, 0. And 1, 0, 0, 1. 1, 0, 0, 1. Now you can see here that a very interesting pattern appeared. And why it is interesting? Because you will find out that you cannot group any of the one in this particular pattern. This one is called the checkboard configuration. So this is the checkboard configuration, and if you already know it, you might be knowing the configuration. So S is equal to A, X or B, X or C input. So you have to remember one thing in checkboard configuration is that the output is the sum is equal to the XOR combination of the all inputs, for example A, B, C, D. So S is equal to A XOR B, XOR C, XOR D. So we will find the variable for the next K-map. here it shows that 0, 0, 0, 1. 0, 0, 0, 1. Next is 0, 1, 1, 1. 0, 1, 1, 1. And this is the simplest thing you will do in this variable schema. First, let us group this one. Then this. And then this. There is a twist that we will see after finding the values of this particular K-map. So, C output is equal to BCI or AB or ACI. So this is what we're going to get in this K-map, but there is another way of getting C output. C output is equal to AB plus CI B XOR A.
So let's continue. If I ask you to find the function by using this K-map, it will be very difficult. Why? Because you will try to follow the procedure that we used to do in the K-map. That is, try to combine the possible group of ones, but if you want to get this function, you have to just leave the particular procedure of the K-map. This is 0, 0, 0, 1, 0, 1, 1, 0. Now, I will make the group of these two ones. And I will keep this one and this one alone. And let's see what we will get is AB from this one plus A B bar C input from this one and A bar B C input. The next thing I can do is to take something common from this one. AB plus CI A B bar plus A bar B. So we will have the result of AB plus CI A XOR B. So this is how the carry output is represented by these two ways. In the K-map, at the end of the presentation, we will be having our sum as S is equals to A XOR B, B XOR C input, and having our carry output as this. It is very easy to implement it on the circuit. We will be having a 2-input XOR gate, this one and this one. This one is A and B. We connect the output of this to this, and this as the C input. The output of this is A XOR B, and the sum will be A XOR B, B XOR C input. And this is the circuit of the sum.